Hello everyone, and welcome back to Winter Data Meetup. I hope you all enjoyed the insightful talks and discussions we had so far. Meet Andrei, a skilled data engineer with a keen interest to shaping the future of artificial intelligence and machine learning. Join us as Andrei shares his exclusive insight into the latest trends of data architecture, providing insider knowledge of supercharge your AI and ML strategies. Don't miss this opportunity to explore the evolving landscape of data science, machine learning, and big data, and discover how data architecture influence the future of AI and machine learning and can increase its efficiency. Now, before we dive into our next session, I'd like to take a moment to ask you for your support in helping us grow our community and recognize the peers. Firstly, if you enjoyed the content we are providing, don't don't and want to stay updated on future events and talks, please consider hitting the like and subscribe buttons below this video. Now for something a bit special, in the video description below you will find the link to this talk page where you can provide your feedback for this talk, give speaker a badge and rate the session if you like or if you don't like it. Through the session, if you have any burning questions or insights you'd like to share, don't hesitate to type them into the chat box in YouTube or via community platform. Our team will be monitoring chats closely and will collect all the questions to discuss with the speaker after the presentation. And now, ladies and gentlemen, let's welcome our speaker to share his valuable insights with us. Andrei, floor is yours.
Hello. Hello, everyone. And first of all, I want to say that I'm glad to be part of this great meetup. And this is my debut in this role. And so I try to prepare as well as I can. So today I would like to present my result, like actually it's a result of my review of modern data architecture patterns and how it can help with the machine learning implementation. Of course, it can be useful for BI too. So this is my a hello message, and I would like to say several words about myself. I'm data engineer at EPAM with the 4 years of experience, and also with the 4 projects, quite different ones. As from technology point of view, as well from the business point of view, and from architecture point of view. So one of the reasons why I choose this topic is because before my data engineer career, I worked in Academy of Science, and it seems that I still have some passion for studying theory of anything, and also to look at any process I'm involved in on the bigger scale. And other reason why I concentrate on ML and AI, my previous project, I was involved into helping ML team to create models with data serving as a data engineer. So I divided my presentation into 4 blocks. And first of all, I will do like a little overview of a relation between data architecture and AI and ML. Then I would like to say several words about classic data architecture, like a data warehouse, data lake, and so on. And after that, I will try to cover 3 main concepts, relatively new ones, that looks interesting for me. And at the end, I will try to recap all this information on conclusion and my look at the future of data architecture. So let's start. I believe you know all this abbreviation, but I will go through it anyway, just to be on the same page. So as you see from the slide, AI is like a whole thing, enabling a machine to mimic human behavior to solve any type of tasks. And machine learning is part of it, which is focused on the statistical methods which can be improved with the experience. So in my research, I concentrated mostly on machine learning part, but it could be applied for AI as a whole. And first of all, ML is something that I have experience with, at least as data engineer. And other reason why is part which ML is mm, is of artificial intelligence overall in terms of investing and so on. But before we will see this part on the picture, I have a question for you, because Sergey told me that it should be interactive presentation. So my question for you is, what do you think? What % of global datasphere is now used for AI? You can write your answer on the chat. I will give you several seconds. So it's just your guess. Please don't Google it. So first option, less than 40%, second 40 to 70, and last one more than 70. I know that there could be some lag, so I believe you wrote it already, and we can go to the correct answer. And correct answer is, of course, less than 1%. So that is quite clear that we have enough work to do to increase this percent, and there should be ways to encourage companies to use AI and ML more. And let's go back to the machine learning percentage of the all AI. As you see from the diagram, it's like a bigger part of it in terms of investing. So it's quite important thing. So why we have only 1%? What stops businesses to implement machine learning? To answer this question, let's look at the main steps of machine workflow. Not machine learning workflow. And as you see, from the beginning, we have to get in data, clean it, organize, and prepare data feature. And then after that, we train model, we test data, we improve it, we test it again, and we get result. So to do it properly, to create really useful models, we need to have quite high level of data maturity in organization, and big part of it is modern data architecture. Also, I have some fun picture. Actually, it's only fun picture that I found when I when I was searching information for this presentation. So enjoy. 2 words about data architecture. There is different definition of it and it's quite complicated to define it 100% correctly, but at least it's quite obvious that it contains several big parts, several important components, and you can see it on the slide. But today we will concentrate on 3 of them. It's data storage, data integration, and data management, actually metadata management. And last one is like most important for the modern data architecture. Okay, so to see why we actually need new approaches to data architecture, let's look at the classics. And by classics, I mean in these 3. Actually, we will talk more about data warehouse and data lake and data marts. It's like I will skip it. So let's start with the data warehouse. Data warehouse was good solution for its time to prepare information for reporting, but as data volume started to increase so rapidly, it became too expensive and too complicated to store it on a star or snowflake schema. Other problems with that, if we're talking about big data and machine learning, which is usually used big data, it's high cost to support it for the big amount of data, no support for semi-structured or unstructured data, and also it's by its definition and design, it's not designed for machine learning application. It's more for the reporting. So next one is data lake, and it was arrived together with the big data. So it provides ability to work with all types of data, also as data should be transformed afterwards. There is no issues um, with the amount of data that we want to store. And as you see, data lake was used for machine learning because as data scientists, they may have to have some specific data, and they can access them immediately. And it's not depend on data engineers who should provide data from sources to data warehouse. But anyway, after some time during which data volume was still increasing and even faster than before, data lake limitation started to be an issue there. And first of all, data lake doesn't support ACID for transactions, and it's one reason, and there is some others which provide bad quality for data. Data has poor availability and integrity. Also, data security and data governance was the issues. And finally, data stagnation problem, because when you have huge amount of disorganized, unreliable data, it's quite difficult to create proper data insights from it. And also, I believe you see quite often this combination of data lake and data warehouse. And in this case, we have data lake like a main source for all data, and also data lake is source for data warehouse, which is in its turn structured data and provided to reports and BI. And this solution is trying to eliminate problems with each of its components, data lake and data warehouse, but with some price. And this price is complexity and cost, because we need to provide consistency between these two systems. So after this like overview, what's wrong with them? From my point of view, traditional data storage and processing methods are no longer sufficient because they cannot simultaneously reduce or solve three main issues. And first of all, it's high cost, it's lack of flexibility, and it's data disorganization. When we have just a huge amount of data and we don't know what is correct, what is not correct, which is from which data is going from which source, and which source is better than other. So it's a data governance problem as well. So finally, we are moving to modern data architecture, and we will see how this modern data architecture patterns is trying to solve these three issues. And it's important to highlight that why we have such a differentiation between classical and modern data architecture. And there is a shift in perspective. And in modern data architectures, data is used as a center stage. And beside that, there is such a definitions as a data democratization and data decentralization, and I will talk about it lately. Today, I would like to talk more about three of them, three main concepts: data lakehouse, data fabric, and data mesh. So let's start with first one, data lakehouse. Because at least there is no new words in definition, not definition, in the name. So as we can understand from the name, it's some type of combination of data warehouse and data lake. And I showed something similar previously, but there is important difference there. In data lakehouse, we don't have a separated data warehouse and data lake. Basically, we only have data lake, But on the top of storage layer, we have metadata layer, which is responsible for all cool stuff that Data Lakehouse is known for. So I would like to focus more on it. Let's go there. So metadata layer in Data Lakehouse is like a foundation that it's defined this architecture pattern. And it's something like a unified catalog which provides metadata and use it mm, for providing next features. It's ACID support for transactions, it indexing in data versioning, and so on. So what it gives us? Several advantages, and one of them is that we need to store data and in data lake and in data warehouse and supporting consistency. So we cut the cost hugely because stored data in data warehouse it's quite costly. Another one is we have data more organized if we compare it with data lake, because we can have index, we can have ACID. So it's something between data warehouse and data lake, but not so restricted. And other one is data can be retrieved faster and easier. Again, if we will compare it with data lake. Regarding data lakehouse implementation, I didn't go too deep into it, but as I see it, first of all, you need to have data lake itself. So it's important to notice that the data lakehouse, it's not something that you have used instead of data lake, but it's like additional features to data lake, which will allow you to do the stuff that I just described. So for now, if you have ordinary data lake with injection layer and so on, after that, you could add metadata layer, and there is several solutions for it, like Delta Lake, Apache Hudi, Iceberg, so on, and also some analytic engine to work with this metadata, actually to use it to retrieve information. Okay, let's move on. And next one is Data Fabric. And Data Fabric is more like a new approach to data management that usually use metadata, machine learning, automation to combine together data of any format from any location, and it should be easier to people who consume this data to get it. In other words, it's not something, again, as Data Lakehouse, it's not something that should replace Data Lake or Data Warehouse, but instead it should help with data organizing access to data without data centralization. Because in Data Fabric concept, we don't have to move data into some central storage like data lake, data warehouse, or something else. We leave data where it is, and then after that we use metadata to get this data. Also, Data Fabric should simplify data access for all users, and it should be no code or less code approach. So how does it work? In Data Fabric concept, metadata management and data abstraction are playing even more vital role than in Data Lakehouse, because we don't store data in one place. Instead, we leave it as it is. After that, we build connection to all the sources in all places. After that, we collect metadata about where we have what and in which form, in which format, and so on. And after that, we build logical connections between entities. We build dependencies between entities, and we store all this data catalog in graphs form. And it's used machine learning in this process to actually build these connections and dependencies. And as now we have this detailed data catalog, we can process requests from BI or data scientists like this. We have requests, for example, like I want to see all sales from for this year, And using metadata catalog, we know where all related information is stored. So we can, using metadata, again, we can create queries for each of the source, and we can run these queries for each source and get parts of data. And then we clean it, transform, combine, and send results to the requester. This slide is like something similar that I just said, so I will skip it. And considering this approach, data abstraction is like a most important part of it, I would say. And let's look at it in more detailed way. So first step is to be able to see all related data from all different sources, regardless its format. So we hide location details, format details, and so on. And after that, when we retrieve the data itself from the sources, we do next step, which is to clean, filter, combine data from the sources and provide this result to requester. So to sum up what this approach gives us, we again, there is no need to store data in a data lake or in data warehouse and support that's all. So we cut the cost hugely there. So because we leave data where it is, and we retrieve only data that we need for this request. So data is getting more organized in data fabric, and also new data integration can be automated, because machine learning is used here a lot, just for data cataloging and meta data management. Okay, and last but not least is data mesh. And if you will look at the picture, you can see that the main difference between data mesh and, let's say, classic data warehouse or even data lake is data decentralization on even more profound level that it was before. Because now each domain collects its own data, organize it, clean it, and provide it to ML team in form of data product, for example. And that means that each domain has to have its own data team. But it's like a small data team, and this data team is quite informed about data that they have, and should not be any data stagnation. To understand this more in detail, we need, first of all, look at two main concepts there. First of all, data product, which is a logical unit that contains all components to process and store domain data. So it's what this domain can provide to all organization as a useful and useful information. Okay, and data contract is something that describe how we can use this data. So it's structure, format, semantic, quality, and it will help to exchange data products between different domains. So to understand it more clear, let's go through the 4 steps of data mesh creation. And if we will start with the 0 step, that means that we have for now just only operational database, and we do nothing with that. So it's just there. First step is when we start to get some analytic from this operational DB. And of course, it's not best way to do it, but anyway, at least we can have some insights. Second step is we create separated data platform where we collect, clean, and aggregate data to create from what we have first data product. So for now, we use only data that we have in our domain, and we have first data product. Okay. The next step thought is quite important for this concept, because now it starts to be data mesh. Actually, now we can use external data products, which is here, and we could combine it with our products and use it for our ML or BI or anything else. And fourth and final move, we publish our data product. We use data contract for it to enable other teams to use our product for their needs. So this way, we could exchange our data products. And if you will imagine multiplying this process for each domain, we are creating actual data mesh. Of course, there should be also main data team which will support this whole system and do data governance, because at least there should be some rules how to create data products and how to create data contracts in the same manner. So it should be some policies that all domains will be like comply with. So to sum up what it gives us, data is becoming highly organized, clean, and reliable. No problems with data stagnation, because when we have a small team which is responsible for small domain, it's quite easier to understand what data we have. Do you have useful information or not, and create proper data products. If we compare it with the solution where we have huge data team for one huge data lake, and sometimes it's quite problematic to know for sure what we have is what information do we have. And also we cut cost of centralization data storage and its support, because we decentralize it at the max. So conclusions and what the next. The last part. And I decided to combine it into one slide, because as I see it now, there is a trend of artificial intelligence and machine learning being used for modern data architecture concepts, and vice versa. So I think that we will see like an intensification of this process even more in the future, but it's only my guess. So okay, so thank you for your attention, and hooray QA. It's a little bit of poetry there from me. So if you have any questions, go ahead. I'm ready.
Yeah. Thank you very much, Andrei. Very interesting, detailed presentation. Now let's move to questions. So probably first question is, so what data volume is used to train models? Is it usually big data? Or it can be like simple tables, probably.
Okay, yeah, it can be, but I believe the problem now, it's from one point of view it's problem, from another it's advantage, that almost every serious company produced huge amount of data, and it's now it's quite problematic to identify which data could provide useful information and which not. And if we would just store it in data lake with bad data management and so on, the chances that we could get some useful insights are quite humble, I would say. So I believe I answered the question. If this question was about my experience, that's because presentation is like a overview. It's not my experience. It just theory knowledge. Yeah, my experience was with data lakes. So amount of information was quite big.
Okay, so we mean that simple PostgreSQL database is not enough to store data for is not always enough to store data for machine learning, right?
Yes, because it's enough to store it, but to use it, not enough. In the case where you have huge amount of data, I will say it again because it's quite important that for now amount of data it's not equal to amount of useful data. So data governance and metadata management is quite important. But if you will try uh, mm, to store this amount of data in their data warehouse manner, it will be quite expensive.
Okay.
So it's
Yeah. So,
other problem.
so what are the advantages of data fabric over data lakehouse? Probably mentioned it.
Yeah, I mentioned it because from my point of view, mm, there is similarity that and this similarity is uh, using of like another level of metadata using. So we still have unstructured, semi-structured, structured data in data lake, but we are trying to somehow organize it. So we try to implement some features of data warehouse, but like a main difference that in data lakehouse, at least we store all this data in one place, which we called data lake. And in data fabric concept, we don't have to do even that. We just have to provide connections to this different types of storage. And maybe nowadays it's quite useful because there is huge amount of different tools, different providers, cloud, on premise, and so on. And I believe many companies are stored their data in too many different places, and maybe this solution is more appropriate for them if, for example, they don't have data lake yet.
So it means that data fabric can refer to data lakehouse, to data lakehouse.
Refer,
You mean, so you mentioned that data fabric just store connections to different databases, to different places, so it like coordinates.
Yeah. It could be combined actually, and it's more like a data management concept. So if you already have data lakehouse, then like a whole concept of data fabric, it could enhance the solution overall. So it's not necessary that it should used instead of data lakehouse. But if question was about difference, I said that in data lakehouse concept we have one source, and which is data lake.
Okay, and yeah, so we also have we'll have a question about data mesh. So what can be an operational database in data mesh? Yeah, you
Actually,
just
I
shown
would
it.
like to answer you, but I don't know. I didn't go into implementation details. I just read about the whole concept and how it looks at data architecture from like a different point of view. So I was looking for this information. As I know, there is no ready solutions for that. So you cannot just buy some tool, install it, and it will be like data mesh. So I believe there is a list of tools that could be implemented, not implemented, but could be used together to create data mesh. But main thing, as I think, there is a concept of relation, not relation, but concept of decentralization. So I believe it's a main one, and the implementation and its details, what tools to use, what concept, or not concept, but what database to use, it's secondary there.
Okay, got it. And yeah, I don't see any other questions. So okay, and that concludes our session. Thank you all so much for joining us today. We hope you found this session insightful and inspiring. In the video description below, you will find the link to the talk page where you can provide the feedback to the talk, give speaker a badge, and rate the session if you like or if you don't like it. Also there you can leave your questions and they will answer them after the session. Additionally, if you'd like to revisit it, you can download the presentation on the talk page or just watch the recording. So check the video description and find the link. Thank you very much, Andrei, for coming. We could not do it without you.
Thank you. Bye.
Thank you. Goodbye.